In this lesson, we're going to talk about taking a number and writing it as a product of prime numbers. Now, this is a preliminary lesson which will help us in reducing fractions in our next lesson. But today, in this lesson, we're going to talk about prime numbers. Okay, a prime number is a natural number, which is a counting number, greater than 1, whose only factors are 1 and itself. So if we talk about a few numbers, we look at the number 2. It is prime because there's only one way to factor 2. 2 times 1. 3. 3 is a prime because there's only one way to factor 3, and that's 3 times 1. The number 4 is not prime. It's what we call composite because yes, it is 4 times 1, but it is also 2 times 2. And when you can come up with an alternate way to factor it, other than itself and 1, it's not prime, it's composite. So 5 would be prime. 6 would be composite because not only do you have 6 times 1, but you have 2 times 3. 7 is a prime. 8 is composite, and so on. Sometimes to determine if a number has factors other than itself and 1, it is useful to look at some divisibility tests. A number is divisible by 2 if it's even, meaning it ends in 0, 2, 4, 6, or 8. A number is divisible by 3, and this might seem a little weird, if the sum of the digits is divisible by 3. For example, 144. It is divisible by 3. Now maybe I don't know how many times it goes in there, but I do know it goes in evenly because 1 plus 4 plus 4 is 9. Since 9 is divisible by 3, so was the original number. So if the sum of the digits is divisible by 3, the number is divisible by 3. And a number is divisible by 5 if it ends in a 0 or a 5. There are a few other divisibility tips, and you might want to write these down. That's totally up to you, but these first ones are very helpful. All right, what we're going to do in this lesson is come up with the prime factorization of any number. Let's take a look. All right, suppose I have the number 44. I'm going to do this by a method called a factor tree. There's other ways to do it. I like to use the factor tree, so that's what I'm going to do. In using a factor tree, you think of any multiplication fact that gives you 44, and you don't want to use 44 and 1. Anything else. So you might go, okay, it ends in a 4, it's even, so 2 goes in there. 2 goes in there 22 times. If a number is prime, circle it. Okay, 2, yes, that's a prime. Is 22 prime? No, it's not because it's even. So it is 2 times 11. Is 2 a prime? Yes. Is 11 a prime? The answer is yes, because there's only one way to get 11, and that is 1 times 11. So if I want to be able to write 44 as product of prime factors, it is 2 times 2 times 11. And we might write that as 2 to the second power times 11. When you're doing this in my math lab, you're going to need to use the exponent tool and the multiplication dot. Okay, so those are some things. You're going to use your tab arrow when you're up here and you want to get out and make the multiplication dot. You can use tab, or you can use the right arrow key. Okay, let's look at some more prime factorizations. It will not be until the next lesson that you see an application for this. Why are we studying prime factorizations? All right, prime factorization of 45. All right, will 2 go into 45? No. Will 3? Yes, because 4 plus 5 is 9. 3 goes into 9, so 3 is going to go into 45. 3 goes in there 15 times. Is 3 a prime? Yes, circle it. Is 15? No. 2 won't go into it, but will 3? Yes, it's 3 times 5. Now, you might have gotten these in a different order. Let me show you. Suppose that you had started with 45 and you said, well, the first thing I thought of was 5 times 9. That's fine. Is 5 a prime? Yes. Is 9 a prime? No. And how can I factor it then? It's 3 times 3. Now, I hope you can see that it does not matter which way you've done this. You've got a 3, and a 5, a 5, a 3, and a 3. Let's write our prime factorization smallest number to largest. I have 3 to the second power times 5. So no matter how I started, I get the same prime factorization. Whoops. Let's take a look at number 3. I have 16. Well, let's see. I could say it's 2 times 8. 2 is a prime. 8. Yes, that's 2 times 4. All right, 2 is a prime, and 4 is not, so I can factor it. 2 times 2, prime, prime. The prime factorization of 16 is 2 to the 1, 2, 3, 4th power. The next one, the number's a little larger. It's a good idea to have your calculator handy. I have 232. Well, I don't know factors of 232 off the top of my head, but I do recognize that this is an even number because it ends in a 2. So I'll divide it by 2, and 2 is going to go in there 116 times, and that's a prime. Now 116 is still even, so 2 is going to go in there, and it's going to go in 58 times. 2's going to, whoa, excuse me, 2's going to go in there again. 29 times. Now, I'm looking at the number 29. It's no longer even. 2 plus 9 is 11. That's not divisible by 3, so the number's not divisible by 3. I know that it is not divisible by 5 or by 7. And as you think through, you will realize that 29 is a prime. So the prime factorization of this is 2 to the 3rd power times 29. All right, last one to practice, 114. You don't always have to start in the same place I would, but if the number's even, I usually start with 2. So 114 divided by 2 gives me, whoops, 57. Keep the 2. Now 57, what times what gives you 57? 2 doesn't go into it, but 3 does, because 5 plus 7 is 12. So that's how I used my multiplication fact, and it goes in there 19 times. So keep the 3, 19. There is no multiplication fact that gives me 19 other than 1 times 19. So the prime factorization of this is 2 times 3 times 19. And it's not a bad idea to check your prime factorization when you're done. All right, in the next lesson, we'll talk about how can that be useful in working with fractions.